Sorry, I got interrupted mid video. Yeah, as I was saying, according to in given condition, we have given out these four cases depending on what input we get, and we will print an ASCII code according to that. So on to the example 7.24. We have configured DDR-B as input in this and DDR-C as output. Then apply while loop and the if else condition. So here is the condition. If it's true in port C, we will get 1 port C. Otherwise, we will get 0 port C. Yeah. So we'll get output at port C depending on what we are given at port B. If the condition is met, we will get an 1 or high signal, or if it's false, the condition is not met, then we will get 0 at port C, low signal. Yeah, that's pretty much it in this. Yeah. We got 0 here, as you can see at port C at 12th pin, we have 0 low signal. Next we have 7-25, in which we have two things, one being the LED and second is a sensor. So we are taking input at DDR-B, port B. So we are taking input at port B from sensor and giving output to the LED. Basically a sensor will detect a signal and give output to the LED at port C. Here we have a condition if else statement which will tell us if the LED is getting a signal or not. Here we have applied the condition, as you can see. The sensor will probe if it's true or if it's false. If it's true, then we will get input at port C, meaning the LED will turn on. And if it's not true, then the LED will remain off. So in this example, we have declared this 0x29 x value to a variable named myByte, and then we have declared DDR-B and DDR-C, port B and port C as well. And then we have another variable named x, and in this variable we have applied AND operation myByte and 0x0f, which is 111 15 decimal. So then we have port B. On port B we have applied OR operation onto the x and 0x30 hex, and at y again we have myByte 0xf0. This time it's 11110000. Then at next we have y as greater than 4, and then again at port C we have applied another OR operation between y and 0x30f hex value. So yeah, that's it. On to the next example 7-31. In this example we have port B, port C and port D, all three of them as configured as outputs, and we have unsigned character x, bin byte, d1, d2, d3. All these are variables that we have declared here. Then we have given value hex value of fd, which is, as we can see here, f means 1 1 1 and d is 13, which will amount to 1101, I guess. Then we have divided bin byte. The bin byte, the value byte has is divided by 10 and is stored in x. Then in D1 we have the here we have saved the remainder of uh, bit byte divided by 10 into the D1. Same here with x, and then x is divided by 10, and then the value of all D1, D2 and D3 is given respectively to the port B, port C and port D. The output will be displayed on port B, C and D according to what values are given. So yeah, here we have pin 12 and 13 is high, and all other 14, 15, 16, 17, 7, 8, all those are off, low signal. Also we have here 23, 25 and 29 is on. So yeah, so on to the last example of this chapter, chapter 7, which is 7-34. So here we have another library for pin, and then we have started by declaring a variable x, and then declaring another variable rega register a, which we have given value of 0. We have applied a condition here, and then a for loop here, which will run this entire operation for 8 times actually, from 0 to 7 by the increment of 1. The output will be stored in a rega variable that we have declared here, in the register a variable. I don't think that there's any output going on, like we won't get any output on the Arduino board. This is a generic type of program that we can understand mostly from just looking at the code here. On to the next chapter, chapter number 9, and this is the first example that we have been given, 9-39. So in this example, what we are going to do is that, let's see, we have declared port B as an output port and port, then we have here a while loop in which we have given a value of 0x, x value of 55, and we have added a delay, function of delay, and the size of this delay is unknown. Then again next we have port B, and we have given a value of 0xAA, meaning 10, 10, x value. Next up we have declared a function of delay, and we have defined the function of delay right here, which have been called 2 times up in the main function. Also we have used timer flags in this example, 3 of them actually, counter timer, and other 2 are right here. Then we have another flag for clearing all this. Yeah, let's see if it works on Proteus in circuit simulation. Yeah, it's working. So this is basically bits are changing with a little bit delay. Yeah.